Good morning, good afternoon everybody. My name is Paul Roberts and I'm the Design Life Product Manager, and today I'll be doing a webinar on the new distributed analysis and high performance computing capability within ENCODE Design Life that was introduced at ENCODE 9.1. The agenda for the day, I'm going to a couple of slides on the current product and where the different products fit in terms of this functionality. A little review on interactive processing within ENCODE Design Life to show we're all up to speed on what that involves. A little bit of background on the distributed processing and why we're doing that, and what needs to be modified in your flows in order to run within the distributed mode and batch. Then a demonstration of the process, how to go from a standard flow all the way to running that process distributed, a little bit on benefits, and then a question and answer session at the end. Okay, so there you see the three ENCODE products. The one we'll be concentrating on today is the one on the left, ENCODE Design Life. So this is the calculation of fatigue calculations from FE model results. The one you see in the center, ENCODE GlyphWorks, is in the same environment as Design Life, but working from measured test data in this case. So more complicated type analyses, but from test-based data, still doing world fatigue analysis, but from strain gauges as opposed to from an FE model. And the one you see on the right, ENCODE Automation. This is to enable you to manage large amounts of data and automate the analysis processes within that, and runs GlyphWorks in the background to do any GlyphWorks analysis on those large amounts of data, and then facilitate the sharing of that data and the results about your organization. So this is a web-based interface, so access from anywhere in the world as a web interface, and access to all your data in the database. So we'll be concentrating today on Design Life, and look at now some of the reasons for doing distributed processing. And main reason, they're finite element models all the time getting bigger. There's now much more availability of high performance computer environments, so you can improve the overall simulation output using those. And as of Design Life 9.1, we've added the capability to distribute your analysis jobs across a number of machines or nodes on a cluster in order to speed up the analysis process. We've always been able to run multiple threads in Design Life, but this has the capability of those threads being on a number of machines. In terms of licensing, that each slave analysis process which runs on the different machines picks up thread licenses as normal based on the number of processors used. And currently this uses the Intel or the Microsoft MPI implementations that have to be loaded on each machine. We include the Intel MPI as the default runtime installed on the install kit for 9.1, and very soon we should be adding the IBM MPI installation to this. We had some problem with the licensing of that via IBM, but that's now been sorted out, so that will go in very soon, very latest in version 10, but also before that probably. We now look at the interactive process, and so this is a flow process that you will all be familiar with, the normal way to run a Design Life process interactively, where you have a fairly simple flow process, but on the left you have at the top your FE model input, so you've done your FE stress solve, for example, and you pull in the results from that in whatever FE format you've got. Below that you have time series files that you might be using. So in this case, combining the time series with the quasi-static load cases you have in your FE to give you a stress history over the entire model. The SN analysis glyph in the middle in this case, and then on the right you have results outputs to the FE model and to a table maybe, and to any FE results file format you might want to save that to. So this is the typical process for running a standard small process within Design Life. And we have an easy way of running that process. You open the process up, you can then drop your FE models on, drop your time series on, hit the run button, run the whole process, or maybe run one glyph at a time if you want to step through from for certain reasons. And while that's running, you get an in-process light, and you can see where you are in that process and how you are going through it. And also in the diagnostic window, you get some progress execution. Also within the design life glyph, you get a run status to show you how far through you are through your entity list, and also a log of where you are in the job in terms of the overall position. So once you've got that process interactively, you can then save that. So the normal sort of save is to save what's called a flow file. So that is saving the glyphs, pipes and properties that define what you want your process to do. So that's not saving the data, that's saving the process that you can then call back, keep your standard processes, recall your standard process and drop on your new FE file or new load files and run that standard process as it is. At version 7, we also added the ability to save that process with its data. So that means it saves the process along with the inputs and results that are currently showing in that flow. So if you run a very large design life job, for example, you can save it with the data. So when you pull that file back, you will see the displays as they were at the end of the job. So it may be useful for if you've got large jobs and you want to keep that active and do that. You can always then save the results files and pull them back, but this just gives you a way of saving the overall process in that way. In terms of batch processing, it's very similar to set up the process. You have a very similar process to start with. So it's very similar to building a standard process. The main difference is how you handle the results. The process you see on the screen now is just sending the results to the FE display and to the data values display so you can see the results. What you might want to do in a batch type process is to save those files, otherwise you won't have any results at the end. So you may replace the display with an FE output or add that to the process as well, which you'd generally be doing anyway. But you definitely need an FE output to record those results, and maybe the multi-column output to save the text version of those results. So just to make sure you've got the output glyphs to save your results back. And in terms of those output glyphs, you can use standard metadata to name the output. So in this example, we're picking an output format of encode FER file, which is the standard encode fatigue results from FE. And in the output file name box, we're picking up the test name from the metadata and adding some extra text to it to create an output file name for where you want to save that. And one thing to remember is to set the override to yes when you're going to run this in batch. And then you will get the output overwritten to each file. So each time you run the batch process, you will get the results you want. Also, the other thing to remember, we have a list of exposed properties on each design life glyph. Now, these are the only properties you can affect within the process by changing them within the batch run. So if you want to change any particular properties, for example, and they're not exposed, you need to expose those properties with the Edit Exposed Properties option. That allows you to pick any of the properties that are set within the design life glyph, expose them on the front of the glyph, and then they're available to be set either by metadata or by batch lines within the script when you run from batch. The differences when creating a process for running distributed is the only difference is how we handle the file input. Currently, the FE input glyph is the only input glyph supported. So your FE model can come in as standard from an input glyph, but any inputs in terms of time series, vibration input files, or maybe material maps must be done directly within the design life interface. So there's an object you can add to pull those files in from file as opposed to from the pipe. So it's a matter of changing those in the advanced edit screen in your process to pull those files in directly. I'll run through that in the example in a minute just to show you what you need to do for that. So the quickest way and easiest way to run a batch process within Design Life and GlyphWorks is once you've got the process on the screen, you've set the options up you need to run for batch in terms of picking the files up directly from the file and not from the pipe. And then there is a Save Process for Batch option on the file menu. What that will do is save 3 files, a new flow file, with the name you give it, a corresponding BAT file or an SH file on Linux to run, and a script file which it uses to load the properties into the flow. Then running that batch file will execute flowproc in the background, run that in batch, and run either a DesignLife or a GlyphWorks process in that case. The three files that creates, a new file name you give it with a flow file, a script file which has got the script in for setting the input files and the other properties you might want to change, and a batch file to run that process with that script. Once you've got this script file, you can then edit that as much as you want. So if you want to modify at that level to change properties within the process, you can. In order to run that easily in a distributed mode, we've added a new utility program within the environment called DT-Distrib. This you will find on your tools menu within the GlyphWorks interface at 9.1. And this is an unlicensed free utility that allows you to run the distributed processes quite easily. And the main way to pick this, if you look at the display, you've got a select batch file option at the top. Basically, this is the batch file that you've just created from the save process for batch. When you pick that up, it will load in the working folder, the flow file name, and the script file name into the boxes below. Those will then be available to run. The next section below, you see where it says distribution. This is where you set up which machines you want to run this on. So the main machine is mine in the center, and then you can add as many slave devices as you want. So you can then set up the number of machines on your cluster you want, and then the communication between this machine and those machines can then be tested with a test communication option. That will then run an MPI process in the background to look at whether it can talk to each of those individual machines. You then have some control over the number of threads you want to run per process. Currently, in this interface, this is the same number of threads per slave machine. You can, within the batch line, change it per machine, but for this interface, you can only set one number for each of those. And then at the bottom, you have the Run Job Now option, which will then run that process on those number of machines you've set up. So I'll show you this in the example in a second. The output you get from that, test communications, runs the communication test, tells you whether it's passed. When you're running the job, you get a job progress box that will show you how far through the entities you are and how many runs your analysis definitions you've got, and an estimated runtime. And at that point, you can abort the job for that interface. You also in there can get hold of the complete command line that this generates and runs. So you can use this to set up your own BAT files, or maybe use for your job distribution programs you may be running. So if you've got job scheduling programs, you can use this to set up the proper batch lines for that. Now just jump to a demonstration, drop out of the PowerPoint for a second. So the first thing to look at, this is a standard simple process where I've got a time series input. So in this case, to run this in distributed in batch, I would have to remove the time series input, so I can delete that input glyph. If I then go to the advanced edit screen within the DesignLife glyph, I have a time series input from pipe. So what I need to do is replace that, so I can delete it there, add time series from file, and at that point I can then browse to the file or set this in the script, but I can pick up my time series file directly. So this process, once I've got the FE model on, is then ready to run interactively. You could run it, but also this is now available to run in a batch method that is running distributed. So then look at the second example. So this is an example that is taken from our new worked example that is available in DesignLife 9.1. work example 22 is a new one we've added to show the distributed mode. So this is the same thing. We have an FE model, and in the advanced edit screen here we can see that there's the time series file I'm picking up directly. So at this point this could be a duty cycle if it's more long analysis, or a number of time series files. So all I have to do to run that in batch, distributed, save process for batch, write this to a new flow file name. This then creates a batch flow file, a bat file, and a script file that will load all the properties in. If we then look at the tools menu, you've got the DT distrib process on the tools menu. I can now run this. So I select the batch file. When I open the batch file, it loads up this particular working folder, the flow file name and the script name. So that is now ready to run. In the distribution section, I've got my own machine as my main machine and a second machine to run some processes on. And at this point you can add a list of machines that are available to use. There's some security things you need to do this, but it's just standard network capability you need to be able to see the data across these different machines. I can then test the communication. So this will check whether this machine can communicate to the others in the right mode with MPI. And now I should be able to run that job. So at this point it is separating parts of the process off onto the different machines. It does this in a way initially to find out which are the fastest machines. That was very quick. It's a very quick example just for the demonstration. So it starts off by putting a small amount of data to each machine, works out which is the fastest, and will keep putting more and more to the faster machines and less to the slower ones. So you should get the fastest normal process you can. Now before we look at the output from that, we have added a couple of extra things in at this stage to help you with monitoring that process. So within the interface you can see I've added a logger file. So this is a file that gives you the same information as you normally get on the show button within the interactive mode. So whatever information you normally get there, you can see in this logger file, and that's now available to view at any point during the analysis. So you can see how far you are through the analysis from that point. We've also added a progress file. So this is basically the status information in terms of number of entities it's solved out of the total number. So you can see that as a running progress throughout the analysis. So if you've closed down your DT distrib interface, you can still find this file and look at that file input to see where you are. And the extra output we've allowed is this property called output distributed source. So that will add to your output file the number in the rank of machines you've used and what the machine name was that's done the solve for each different entity in the analysis. So if we have a quick look at those files to show what has come out, we've got the job progress file. So that's maintained at the end, showing you where your job progress was, at the end. The log file basically is how many threads I've started on each machine and which machines I ran on. And then if I look at the output CSV file, so I've saved the CSV file as well as the FE results file in this case. You will see I've got two columns called computer rank, which has got number 1 or 0 depending on which machine it ran on, and it tells you the machine name it actually ran on. So a little bit extra debug information so you can see where those results came from. One thing to mention, you do need a full installation of design life on each machine that you will be running processes on. And in terms of the directories, you can have a shared directory for all the analysis files, so they can be, as long as that shared directory is visible from each machine, it can run data in a shared directory, or you can run it with copies of the data on each machine. So not the FE file, that needs just to be on the master machine, but all the road load data files, if you're running separate directory, would need to be available on each machine. So what we've looked at today, batch processes can be easily created with an encode and run. And now those batch processes can easily be distributed on a number of different machines by three main methods, either using the supplied utility program we supplied, so if you've got an easy implementation, you can just point to those machines and use that utility directly. If you want to change some things within that, you can edit the command files and run the batch files directly from a command prompt. So if you want to change the number of threads used on each machine to balance that thread usage, you can. And also you can take that command file structure and use that for any standard method you might have within your company or any standard job submission system you use to modify that file to use within those processes. Okay, so that's the end of that demonstration for today. So